All right, geometry, this is a special notes. It's a notes that I've never taught this way before. I think it's better than how most people teach this, and I'm not bragging, but I've been reluctant to do it this way because no one does it this way. So it's not revolutionary by any means, but I just think it's easier for students to remember how to do it if we do it this way. So let's go into this slowly. This has to do with special right triangles. If I were to say to you, we have this coordinate plane, and in quadrant 1, we had a 30-degree angle, like so. If we draw a reference triangle, this would be a 30, 60, 90. And if I said to you, well, let's make the short leg 1, what would you say the hypotenuse is? Hopefully you would say it's twice that, and the long leg is the short leg times the square root of 3. This relationship is true in every 30, 60, 90. Now if we doubled all these numbers, we would have 4, 2, and 2 square roots of 3. It'd still be true. If we had 8, let's say 8, 4, and 4 square roots of 3, it'd still be true. I like to make the smallest side 1. Now what if we were to take the same concept here and we were to draw a 30-degree angle in quadrant 2? We draw a reference triangle, it's a 30, 60, 90. If we, in fact, again, made the smallest side, which is the leg, smallest leg 1, the hypotenuse is still twice that, which is 2. The long leg is the short leg times the square root of 3. The only difference is, since we went left, the x value is negative. Notice these triangles are the same, the scale's a little bit different, but these are the same triangles. Depending on what quadrant you're in, the sign is going to change for some of the numbers. What if we drew this in quadrant 3? And we called the smallest side 1. Now you got to be careful. In this case, the smallest side is going to be a negative 1 because we went down. The hypotenuse, which is always positive, is double that. Opposite 60 is the short leg times the square root of 3. And since we went left, it is also negative. Notice these are the same triangles, just written in different orientations. The only thing that has changed is the quadrant, which then changes the sign, S-I-G-N, of some of the answers. What if we drew this in quadrant 4? Makes a 30, 60, 90. Call the smallest side 1. The hypotenuse is twice that size. The long leg is the short leg times the square root of 3. Make sure you have your signs correct. 1 has to be negative because we went down. In every case, 30, 60, 90. If we call the smallest side opposite 31, the long leg is square root of 3 and the hypotenuse is 2. If you can remember that, you are halfway to accomplishing something that I think is pretty cool. What does this have to do with what we are referring to? Well, if we draw a circle, I'm just going to take all of this. We will maybe reference this again. I'm going to draw a circle in a coordinate plane. Actually, I'm not going to draw a circle. I'm just going to draw a coordinate plane. And I'm going to break the coordinate plane into multiples of 30. So we got 0 degrees, we got 30 degrees, we got 60 degrees, we got 90 degrees, we got 120 degrees, we got 150 degrees. Continuing here into quadrant 3, so the negative x-axis is 180, just adding 30 each time. 210, 240, 270, 300, 330. What I would like to do at the end of each of these lines is to write an ordered triple. That ordered triple being x, y, and then r. And in each case, I'd like the smallest number to be 1. Well, not in all cases, but in most cases. So for example, let's take this 30. If I were to draw a 30, 60, 90 here, and say opposite 30 is 1, the hypotenuse is 2, and the long leg is square root of 3, then my ordered triple here would be x first, y second, r third. Square root of 3, 1, 2. First of all, how is that valuable? It's valuable because if I were to ask you, what is a sine of 30 degrees? You would say that it's y over r, which is 1 over 2. So you know sine of 30 degrees is 1/2. No calculator needed. What's cosine of 30 degrees? Well, that's x over r. We're saying x is square root of 3 and r is 2. It's square root of 3 over 2. No calculator needed. What's tangent of 30 degrees? Well, that's y over x. So that's 1 over the square root of 3. If you rationalize it, you get square root of 3 over 3. No calculator needed. This is powerful stuff. Now, check this out. Well, let's not check this out yet. So we got this at 30 degrees. We got square root of 3, 1, and 2. At 60 degrees, if I were to draw, this is, not perfectly to scale. But at 60 degrees, if I make this reference angle 60, it's a 30, 60, 90. If I make the smallest side 1, the long leg is going to be square root of 3, and the hypotenuse is going to be 2. So my ordered triple, x first is 1, y next is square root of 3, and r is 2. So how is that valuable? Well, if I asked you, what is sine of 60 degrees? You would say that it's y over r, so that's square root of 3 over 2. What is cosine of 60 degrees? That's x over r, so that's 1 over 2, which is a half. What's tangent of 60 degrees? Well, that is y over x, which is square root of 3 over 1, which is just square root of 3. This is awesome. You may not realize it yet, but this is going to get real cool. Now, let's add another one in here. Let's add in 45 degrees, if we were to count by 45s. So let me remind you about a 45, 45, 90. In a 45, 45, 90, both the legs are the same length, and I'm going to call those legs 1, because I like to make the smallest side 1. If those are 1, the hypotenuse is that times the square root of 2, so that makes that square root of 2. If I were to draw this oriented in this direction, in a coordinate plane, x is negative, y is positive, r is always positive. If I were to orient it in this direction, so it's in quadrant 3, x is negative, y is negative, r is always positive. If I put it in quadrant 4, x is positive, y is negative, r is always positive. In each case, absolute value-wise, it's a 1, 1, square root of 2 triangle. Get rid of this. So if I go here in quadrant 1, I'm looking at this 45-degree triangle. If I were to draw it, so this is a 45, 45, 90. Each leg is 1. The hypotenuse is square root of 2. So that makes this 1, 1, square root of 2. X, y, and then r. It's important that you write them in the correct order. X, y, and then r. So that is quadrant 1, and it's all filled out. Well, check this out. Once you get quadrant 1 done, filling in the other quadrants is super simple. 30 degrees is this angle right here. Guess what this reference angle is here for 150? It's also 30. So that means that if we draw a 30, 60, 90, opposite 30 is going to be 1. That's y. The long leg's going to be the square root of 3, and the hypotenuse is going to be 2. The only difference is this x value has to be negative because we went left. So if we take this ordered triple here, we copy and paste it over here, the only thing that we have to change is in quadrant 2, the x values are negative. If we draw this angle in here, so we got 45 plus 45 plus 45, that makes this 135. This 1 square root of 2 would be negative 1, positive 1, square root of 2. 120 degrees, that reference angle is 60, just like this is 60. So if I take this ordered triple and put it here, making sure the x is negative, I get negative 1, square root of 3, 2. What about down here in quadrant 3? Let me add into this 45 degree angle. 180 and 45 is 225. Let me add this also in to quadrant 4. 270 plus 45 is 315. So if I take this ordered pair, because the reference angle is 30, the reference angle is 30 here for 210, it's going to be the same values, but x and y are both negative. R is always positive. This 45 degree reference angle is going to be the same reference angle here. So I'm going to use this ordered triple, but x and y are both negative in quadrant 3. If I take this reference angle of 60, I get this ordered triple. It's going to be the same here because the reference angle is 60. Only x and y are negative in quadrant 3. R is always positive. If I go here into quadrant 4, if I take my original ordered triples, this is 30 degrees. This reference angle is also 30. So this is going to be square root of 3, negative 1, 2, because in quadrant 4, x's are negative. This reference angle is 45. This reference angle is also 45. So it's this ordered triple. But y has to be negative because we went down. 60 degrees has the same reference angle as 300 degrees. So it's this ordered triple, which is 1 negative square root of 3, 2. Y has to be negative in quadrant 4. Now we're almost finished. Before we continue, I just want to make sure that we understand what just happened. Reference angles, reference angles 30, reference angles 30, reference angles 30, reference angles 30. Look at the ordered triples. The only thing that has changed is the signs of some of the numbers depending on your quadrants. This is 45 degrees. This is 45 degrees. These are all 45 degree reference angles. Look at those ordered triples. They are all the same, but the signs have changed depending on the quadrants. These all have the same reference angle of 60 degrees. And if you look at their ordered pairs, they're all the same, but the signs change depending on what quadrant you're in. Now we're almost finished with this monstrosity. We just have the easiest part to do left. What happens if we want to know what an angle is, a trig function at 0 degrees, or 90, or 180, or 270? To write an ordered triple for this, it's not a special triangle, it's much easier. Let's make the smallest side here 1. So if we go to the right 1 unit, the x value is 1. What is that going to make the y value? Well, we didn't go up or down, so y has to be 0. R is defined as a radius. If we go to the right 1, that means the radius of our circle is 1. So the radius is 1. If you check this out, 1, 0, 1. X, Y, R. At 90 degrees, it's going to be 0, 1, 1. X is 0. We didn't go left or right. Y is 1 because I want to choose a number. If I'm going to choose my first number, I want it to be 1. And then R has to be the same value because it's the radius of a circle. At negative 180, which is negative x-axis, X is negative 1, X is negative 1, Y is 1, and R is 1. We went left, that's why it's negative. Didn't go up or down, that's why that's 0. R always has to have the same absolute value as X or Y if it's a quadrantal angle. Down here at 270, we went 0 left or right, we went down 1, and the radius is the same absolute value as the distance that we went. This monstrosity that you're looking at is a modified version of what's called a unit circle. The unit circle in itself is what everyone uses, and I just think, even though this looks complicated the first time you saw it, I think this is more valuable. Your assignment is to memorize this. Now you might be thinking, that is ridiculous. Well, it's not. Because what I would do is I would derive what happens here in quadrant 1 with 30 degrees. I would derive what happens in quadrant 1 with 45 degrees. I would derive what happens at 60 degrees in quadrant 1. Then I would take those ordered pairs and I would just change the signs for the different quadrants. Once you get quadrant 1 done, you can fly through this. As far as your quadrantal angles go, just make the radius 1, and then your x's and y's will take care of themselves. So big picture, how is this helpful? What is the point of this? Well, let me show you the point. Let's say you're asked to find, let's say, sine of 300 degrees. Or you're asked to find cosine of 240 degrees. Or you're asked to find tangent of 225 degrees. Let me show you how easy this is if you have this drawn. 300 degrees is here. Sine is y over r. At 300 degrees, y is negative square root of 3, r is 2. Done. Cosine of 240 degrees, here's 240. Cosine is x over r. X is negative 1, r is 2, so it's a negative 1/2. Tangent of 225, here's 225. Both x and y are negative 1. Tangent is y over x, so we get negative 1 over negative 1. Here's what your assignment is. Your assignment is to practice writing this out as many times as you have to so that you could write this out on a quiz. Maybe that's going to require once. Maybe that's going to require you practicing this 10 times. I don't know. But in each case, these are special right triangles. And just to make sure it's clear, every 30, 60, 90 has the ratio of 1 square root of 3 to 2. Every time. Every 45, 45, 90 has a ratio of 1 to 1 to square root of 2. All right, that concludes this. Have a good one.